Victor Velarde, and I'll be speaking about Theronine, the structure and bonding. General information: molecular formula is C4H9NO3, melting point 256 to 261 degrees Celsius with some decomposition, boiling point non-existent as it decomposes before boiling. Solubility in water: it is soluble. Formal charge: it doesn't have one. It will be at 0. Acidity: pH: the pH will be relatively close to 7. Important known isomers of Theronine: L-theronine. This is naturally occurring in biologically active form. D-theronine, the enantiomer of L-theronine, the L-allotheronine, a diastereomer of L-theronine with a different configuration at the beta carbon. D-allotheronine, the enantiomer of the L-allotheronine, and a diastereomer of the D-theronine. Hybridization will start off at the sp3 alcohol group bonding with a 104.5 degree and a molecular shape of bent. It'll be found at the top left of the molecule. And we'll have a sp3 nitrogen with the bonding of 107 trigonal pyramidal. It'll be found at the bottom of the molecule. sp3 carbon 109.5 tetrahedral. It will be found at the top right of the molecule. sp3 oxygen 104.5 degree bonding bent at the bottom right. Bottom left of the molecule. And we have sp3 carbon 109.5 degree bonding. It will be tetrahedral, and it'll be found at the one of the chirals, the second chiral. And then we will have a sp3 carbon 109.5 tetrahedral at the third chiral. The second chiral. This will be the first, and this will be the second chiral carbons. And we have an sp2 carbon with a 120 bonding angle. Found it will be trigonal planar, found next to the first chiral carbon. Then we have an sp2 oxygen at the bonding of 180, and it'll be linear, found right here at the bottom left of the molecule. Then we go into carbon classification. The C1 carboxyl carbon not classified like alkyl carbons bonded to 2 oxygen atoms. It will be found at the carboxylic acid over here. The C2 alpha carbon secondary bonded to the C1 and C3, and it will be found here in the middle, the both alpha carbons. And then we have the C3 beta carbon primary and bonded to only the C2, which is found over here at the methyl group. Theronine resonance structures, we will start off with the left one, in which the double bond will go into the oxygen, having it become negative as it have excess amounts of electrons into it. And then to create a second resonance structure, we can have the oxygen's electrons into the bonding, having it become a double bond, and the oxygen would then become positively charged as it loses electrons. Acids and bases functional groups. Breakdown IUPAC name breakdown: T2S 3R 2 amino 3 hydroxybutanic acid, butanoic acid 4 carbon chain with a COOH at Cl, 2 amino NH2 and C2 3 hydroxy OH and on C3. Relevant pK values: the carboxylic acid has a relative value of 2.1 pKa. Amino group has a relatively close at 9.1 pKa. The side chain OH is not ionizable to no typical pKa for the neutral, the alcohol here. Functional groups in Theronine amino group: its basic polar form peptide bonds found at the bottom. The carboxyl group, the COOH, acidic polar forms peptide bonds found at the left side. The hydroxyl group, the polar and charge enables hydrogen bonding and phosphorylation at the top left of this molecule. And the methyl group, the CH3, the nonpolar, it's nonpolar, adds slight hydrophobic character to the side of the chain, found at the top right of the chain, the molecule. Types of intermolecular forces: hydrogen bonding between amine and alcohol and the hydrocarboxylic acid. Groups: dipole due to the polar functional groups. Ion dipole when dissolved in water, London dispersion between nonpolar parts like CH3. Dipole moment present due to the polar groups OH and H2, COOH. The Z-Witter ionic form dominate in water. The molecule has a strong dipole moment contributing to high water solubility. Solubility: water high soluble due to the polar and ionic groups and hydrogen bonding. Organic solvents allow solubility in nonpolar solvents like hexane, moderately soluble in alcohols due to some polarity as the basic properties. Amphoric acts as both an acid and base, exists in Z-Witter ion, and physiological pH NH3, and the COO. Lewis acid bases in size, Lewis base NH2 OH, and the COO electron pair donors, Lewis acid COOH, the hydrogen proton donor. Only in acidic conditions can this be found. Important conformations in aqueous solutions, Theronine exists as a Z-Witter ion, NH3, with the carbon connected to a hydrogen and alcohol, and then a CH connected to a CH3, and then the COO negatively bond. The alcohol and amine groups can be intermolecular hydrogen bond, stabilizing certain conformers. Backbone conformations in peptides is important. Theronine beta alcohol makes it capable of side chain hydrogen bonding in proteins. The stereochemistry, chiral carbons and chirality. Chirality, the theronine has two chiral centers, alpha carbon, central carbon bond H, the hydrogen amine carboxylic acid, the CHOH, CH3, all indifferent. The beta carbon, side chain carbon bonds to the hydrogen, the OH, the alcohol, the methyl, and alpha carbon, all different, resulting in chirality. The theronine and two stereocenters can form four stereosimers. Only L-theronine is used in proteins. Diastereomers L-allotheronine, same configuration at alpha carbon, different at the betas. So the chiral centers are found in the middle of this molecule. Enantiomers and diastereomers, we have four of them. We have the 2s3r L-theronine, 2r 3s enantiomer of L-theronine, the 2s 3s diastereomer of L-allotheronine, 2r 3r enantiomer of L-theronine. For an enantiomer of L-theronine, it has an S, goes an S, and then the second one goes in R. First starts off as R. First starts off as S and then goes to become R because of the hydrogen on the wedge. In L-theronine, the first carbon is S, and the second one is R since the hydrogen is on the wedge. For enantiomer L-theronine, it first starts as R. Starts off as S and then becomes R because both H's are on the wedge, so both of them become R. And then for the diastereomer L-theronine, same story, same story. Both of them just keep, both hydrogens are still dashed, therefore having both of them stay as S. Fischer projection of L-theronine, an amino group, amine, a carboxylic group, a central carbon, alpha carbon bonded to the amino group, the carboxy group, a hydrogen atom, a unique R group. Theronine is amino acid because it has all three NH-COH, a central carbon, chiral carbon, the alpha carbon, a side chain, the CHOH, CH3. As we can see here, I have drawn the Fischer projection in which the L-theronine has both R's. Alkyl halides, nucleophilic substitution, electrophilic and nucleophilic sites in theronine, electrophiles and nucleophiles. It will be found at the carboxylic. The electrophiles are found at the carboxylic, and nucleophiles are found at the amine and alcohol groups. Important chemicals and biochemical reactions of theronine peptide bonds. Theronine amino group reacts with the carboxylic acid during protein synthesis. Phosphorylation, the alcohol on the theronine can be phosphorylated. A phosphate group is added. Oxidation, the alcohol group is on theronine can be oxidized usually in strong chemical reactions to form a alpha keto acid. Deamination, enzymes can be remove the amino group from the theronine in the liver, turning it into a compound called the alpha keto butyrate plus ammonia. This is part of the amino acid breakdown. Hydrogen bonding theronine has a polar group, alcohol and amine, so it can form hydrogen bonds in proteins. Synthetic routes to the theronine biosynthesis in organisms from the aspartate via a multi-step pathway involving aspartate homoserine, theronine, enzymes asparkinase, homoserine dehydrogenase, theronine synthase, laboratory synthesis from the glycerine or serine derivatives. Example, protection of the amino and carboxyl group alkylation at the alpha position, introduction of the alcohol and amine groups, deprotection. Chiral synthesis uses a enantioselective catalyst or chiral auxiliaries to control the stereochemistry at both chiral centers. Use of theronine in nutrition, essential amino acid for humans, used in dietary supplements and animal feeds to promote growth and protein synthesis biotechnology used for fermentation process to produce pharmaceuticals, or as a proskewer to other chemicals, pharmaceuticals, proskewer in synthesis of certain peptides and drugs, research model compounds for protein phosphorylation, studies structure function, studies in enzymes and receptors, protein synthesis, incorporated into protein and ribosome via tRNA, that infrared spectrum. The most notables here are the OH, the CH, and NH. The alcohol, CH bond, and the amine bond. IRL Theronine states the infrared for L-theronine states that state matter in aqueous solution Z water ionic, the COO and the NH peaks, the broad alcohol and amine stretch often overlap. If the theronine is dry, not in solution, the COH and NH2 peak become more prominent. In solid states, theronine typically exists in Z water ionic form, the NH3 plus and COOH. Board peak at the 3,300 centimeter overlap, and the amine and alcohol stretches double it near the 1600 and 1400 centimeters, indicative of the carboxylate group. Acid-base properties of theronine. Theronine is a neutral polar amino acids. It contains two ionizable groups, amino group, and the basic pKa 9.1 carboxylic acidic at 2.0. Z-water ion form occurs at the isoelectric point pi. The pi is 2.0, the pKa of the amino group, and the carboxyl group and amino group, and then it'll be divided by 2, and we get 5.5 for the Z-water ion. At the low pH acidity, both groups are pronated +1 charge. At the pi, amino is positive charge, carboxyl is negative charge at 0 net charge. At the high pH basic, both groups are depronated to -1 charge. Theronine side chain does not ionize the physiological pH. Important peaks of the theronine were going to be the 3,300, 3,500. The alcohol stretch, broad and strong due to the hydrogen bonding, 3,100 CH stretch. The sp3 for the alkyl CH is in methyl and ethyl groups. The 1550 to 1560, the NH band amine, the Mi2 band medium from bending of the NH2. And here are my citations for how I got all my information, and that'll be the end of my presentation.